Hey guys, Mike Tierney here with Princess Auto. Welcome to Tech Tips with Mike T. We're talking about small gas engines. So you're in the market for a small engine, whatever project that might look like for you, whether it's building a go-kart or replacing an engine on something that you've already have as a piece of equipment. Tons to choose from. At Princess Auto, we carry some of the largest selection of small gas engines of any retailer. So when you do get into our store, go through our catalog, you got a lot of engines to choose from. So our first house brand here is our blue Power Fist unit. This is considered to be a fairly small engine. It's a single piston, as we say. It does have what's called an oil alert, and that will kind of, if you don't have enough oil in, it will just not allow that motor to start. It's easy starting. This will do what you need it to do on all your basic needs when it comes to selecting a specific engine. And we got a wide range of them. So there's parts available for them. They aren't intended to run 24/7. That's not their level of usage. But for kids' go-karts and some lawn care equipment, if that's what you're doing, those work perfect for that environment. The next step up is our ProPoint. Some of the models, this model here, you can see that it's got a keyway here. This has electric start, so really simple, easy start system on it. You just connect your 12-volt battery to the battery cables that are supplied, and you can start it with electric start. You also have a manual start as well if you choose to not use the electric starter if that's not working for you. The biggest difference, obviously physically, it's a little bit larger engine, it's a bigger horsepower engine. This has a cast iron sleeve that that protects the motor housing, which is aluminum, from superheating. So that cast iron sleeve helps prevent any kind of warping in the piston chamber, and you get longer use and longer life out of this type of engine, our ProPoint engines. Quite a few of the ProPoint engines also have the ability to add a auxiliary light kit. So this is a great option if you do want to have a light running without having to use your battery system. So that's another big benefit of this. And you do go up in a little bit of money, but again, you're getting more of a semi-professional engine at a really, really good price. So the Honda itself, it has, everybody kind of suits it, with the cream colored tank and the red tins. They do have different series. So the two Hondas we have here, there's a GX series and a GC series. When it comes to the GX series, we carry a couple of models to that. Pretty much getting all tin. So really, really robust, very little plastics other than maybe an air filter cover. But your front recoil's, going to be tin. Your tanks are all tin. It's made to, be in that construction industry. Or if you want to, and you got the money and you want to put it on your go-kart or whatever it is, then it's there for you as well. The GC series has a little bit more plastic to it. It's lighter weight. The cost comes down. You've got plastic fuel cans. You got plastic recoil covers and that kind of stuff. That doesn't mean that it's any worse for wear. It's just bringing the cost down, and it's just a series of their line that they carry. They carry a ton of different lines. At Princess, we only carry a few of those. So we've gotten rid of some of the horizontal units, and we do carry a couple of models within the vertical shaft unit. So you can see here that this is a Briggs & Stratton, and we carry a couple of sizes, power ranges in Briggs & Stratton. And typically these things would be used for lawnmowers, possibly a snowblower maybe repair or making a snowblower. Anything that you're going to have a downwards mechanical driven system. So again, it needs to sit in this orientation. So you can see here, the shaft comes from down below. This one is a keywayed shaft as well. It also has motor mounts all on the bottom. So this is the way you want this to be mounted, straight up and down. So to work on these is a little harder than a horizontal shaft because everything is kind of accessible. Usually when you're working on these, everything's kind of hidden under a shroud or something, and linkages can be awkward to get to, or belts and pulleys. So huge market for these. Briggs is one of the better brand names out there. There are some PowerFist units that are available, and these are really good sellers for us. It's just a version of the horizontal. But again, because the oil has to stay within the crankcase, you want to make sure that this is in its right orientation. And then from there, you can change the way that drives through your driveline systems. So if you need for it to go to an axle to go this way, well, then you can use different belts, pulleys, and chains, and different ways to make that mechanical application work. So horizontal versus vertical. These get quite heavy. They also have, in this case, this one also has a starter, so electric start. It also has the ability to run a secondary or a light off of it, and lots of replacement parts for this. Briggs & Stratton pretty much been on the market forever, and they've really figured out how to make it work. This one also has, in this case, if you can see it, basically an inline filter that can, as an accessory, we carry those. So if you're filtering out your fuel, we also have other models that have inline filters that could be hidden. This one's readily accessible. So again, keep in mind, how much power do you need? How much are your twisting forces? And then you can make your selections from there. Kind of the differential between Briggs and the other engine manufacturers, quite often they put their horsepower on there, and sometimes their torque ratings are also on there. So that does differ from some of the other models, and they'll give you, in this case, this one here has a 17.5 gross horsepower. So it's a model EX 1750. So they incorporate that horsepower within that model. That is not cubic inches or cubic centimeters. That is actually their line of horsepower rated products. So they do differ than Honda or PowerFist or ProPoint. So just keep that in mind, just if you're looking apples to apples. They do rate them slightly different. Most of the time now on these engines, they're listed in their displacement. So their cubic centimeter cc displacement. So when you look at the recoils on most of them, you'll see that there's typically a number. Whether that's a 280 or a 390, whatever cc that is the physical dimension of the piston inside the engine, the size of it, and its stroke. And that's calculated into displacement. And they add, depending on how many cylinders there are, in this case these are all single cylinder motors, you'll only get one piston size, and that's its displacement. If you had 2, 3, 4, 5 and higher, getting into the larger engines, they would add all those displacement numbers up, and that would be the displacement of that engine. That has zero bearing when it comes to horsepower. There is no direct calculation to say this engine displacement produces this amount of horsepower. That has to go through a bunch of tests. There's obviously environmental things that affect altitude, temperature, humidity. All these things take into account on how that engine's actually sized. So the manufacturers have typically now mostly gone to the physical measurement because that's really simple through their engineering. But they're, in order to figure out what you want to do and what you need out of it, you need to know that horsepower. So there's a bit of a cheat that I've come up with because there is no direct formula for displacement and horsepower or to horsepower. It's not a quick conversion, but there is a bit of a cheat number. If you take your displacement in cc's, not cubic inches is a different measurement, so cubic centimeters, and divide that by 29. That will get you approximately very close to that actual horsepower that they would have rated that to begin with. So it's a bit of a cheat. It's nothing, scientific, but anything under about 24 horse in the small engine category, you can kind of use that to kind of just guesstimate pretty darn close to what that horsepower is going to be rated for those. So it's a little tip there, divide by 29 if it's cc. If it's in cubic inches, you'd have to convert that cubic inches into cc, which you can do. That is a unit of measurement that can be converted. But then you can divide that by the 29. So keep that in mind if that's, you're not sure how to, what horsepower is it rating, because quite often they're not listed on the engines anymore. So that's the power at the flywheel. So at the recoil side of it, so on the fronts there, that's the power. That doesn't mean that that's what it delivers on the shaft side. So you're going to lose, depending on the model, 10, 15, 20% through the drivetrain and the mechanics through the engine. So if you're requiring a certain amount of output power, you may need to go up in size because that engine might not have it based on the listing unless it says net power. And you can find those. Honda does a really good job on their small engine websites, and they'll actually give you those charts to kind of see those curve charts, performance charts that they've tested that engine at, or that size of engine at. The other way we look at selecting an engine is by the torque. So torque is a twisting force. So usually foot-pounds, inch-pounds, and then there's metric ways. We're going to stay with the standard because that's what most people are going by these days. So they rate those engines at foot-pounds or inch-pounds. So as that shaft turns, it's going to create an X amount of force. Now where a lot of people go wrong is not actually looking at that number. And that number is like the most important because you may have the power to drive your system, but you don't have the torque to turn the wheels or the axle. So all of a sudden now the engine doesn't want to run properly. It stalls out when you put it under load. So knowing what your amount of torque required out of your engine is just as important as the power selection when it comes to horsepower. So those two things in conjunction. Now it gets kind of scientific here because the power rating is based on the highest RPM of those engines. So typically you're running around 3,600 RPM at its highest rating. That's where you get your highest horsepower rating. But you may not necessarily be running that. You may select to run it at a lower power rating. Now on the reverse side, where the torque comes in, your highest amount of torque developed is not at your highest RPM. So it's somewhere in around that 16, 18, 1900 RPM. So yes, you're running it at high RPM to get the most power out of it, but your torque rating is actually at the mid-range line of the RPM. So if you need more RPM and you need that torque, you need to go up in motor sizes to compensate for that difference between it. If you're interested and you're not sure about the science behind it, you don't necessarily have to be a mathematician to kind of understand it. They do a really good job. Just go into their website, their small engine websites. Just like our vehicle engines, we have pushrod engines, and then we have what's called cam-driven engines. So a cam-driven engine does not use pushrods. They use either a belt, an internal belt, or a chain. Quite a few of them are chain. So this model is this model is belt-driven, which is one of the first ones on the market to have internal belt control. Most of them will be chain, and we're going to look at some later on and show you what that looks like inside an actual engine. Now these models here, what does that mean for it? Well, typically, if you were to do a side-by-side comparison of pretty much the same horsepower engine, this engine will have a longer lifespan under ideal similar use. It's going to run cooler. So that means that If the engine's running cooler because there's less moving parts, it means that you can run it longer. It has less moving parts, so there's less things to go wrong. Doesn't mean that these aren't any good. It's just as new technology comes through our vehicle engines, they're passing some of that down now to the smaller engines. So this is kind of one of our newer models that have come to our lineup, and this one has a internal belt versus a chain, and it's kind of the first of its kind in that form. So that's a great option for maybe getting away from a push rod. Not to say that they're not any good, that's for sure. They've been around for 100 years. So we've changed the view a little bit. So this is what an engine, if you try to strip it apart, just kind of bare bones, get the tins off, get all kind of the tanks off. We're going to kind of show you the main differences between a cam-driven engine, whether it's a belt or a chain, which is normal in the industry, whereas the Honda uses that belt. And I'm going to show you what a push rod engine looks like if you don't know what that looks like inside. So let's start with a cam-driven engine. So in this shot here, we've got our crankcase down below, our output shaft as a horizontal, and we have a piston chamber that moves up at a certain angle. Now there's things that are going to happen down in the crankcase that have to transfer the operations to the upper part of the engine. Okay? So in the upper part, this is where our valve cover would be covering. We would take that off, and we see the mechanisms that help the engine do its operation and create the power. So we have basically lifters and mechanisms that move up and down to open our valves and close our valves for exhaust and for air fuel to come into it and dump the exhaust out. So there's two. And then we have a way to connect what's going on down below to what's happening above. So in this case, this uses a chain and sprocket system. So there's a chain that goes down, there's another sprocket down inside the crankcase, and that connects what's happening. So what that does is it directly acts on your valve system to open and close to allow the cycles of the engine to work. Way less moving parts. Again, I can't stress that this is going to be way cooler as it runs, and there's few parts to worry about. Now there are tensioners that you do have to keep an eye on to make sure that the chain isn't wearing and you put some more tension on it, but the maintenance on these are far less. So this is a version of a cam-driven engine. Now the valves, there's two valves, intake and exhaust. They open and close, and they're closed at the same time when we make the compression stroke. Well, they are directly over the piston. So that's how we rate them as a OHV, overhead valve, and this is a cam version of that. So the valves are overhead. It's more efficient for the engine, so it's a design feature, which most engines are going to nowadays. And the spark plug is typically up and above there. Some of the older models, 25, 30 years ago, they used to have the valves beside the piston chamber. And that was very common. That was kind of the first designs. They found that for more efficient fuel burn, more efficient stroke power, you move the valves over top, and that's where we get our OHV, overhead valves. So the cam version, let's just move that aside a second. Now I do have a piston-driven engine a little bit further apart, and we'll be able to see some of that. So again, we have our horizontal shaft. You'll notice that this is a bit different than the previous one, whereas these are different styles of shafts. I do have the crankcase open, so you can see all the workings that go on. Now, in order to get what's happening here, to control what's happening above, we have to create some sort of linkage. Now, this does not use a chain. It uses rods. Here's a couple of rods that we have pulled out of engines before. You'll notice that one rod, this rod here, is quite a bit thicker than this rod. Now you'll notice there's a little problem with this rod. It's actually bent. And that is a reason because something went wrong with that engine and the timing of that engine got out of whack and things were opening and closing when they shouldn't, and these bend. Sometimes if you watch a racing program, oh, I threw a rod or I bent a rod, that means that these things are physically mounted inside, I'll show you in a second, and these are what move up and down to control what's happening here to what's up in your upper part of your engine versus the chain. This push rod's actually out of a diesel engine, so quite a bit more robust, thicker because of the compression rates that the diesel engines go through. So this is common in these small engines that are push rod engines, and they're common in the engines that you have in your vehicles that are considered to be push rod engines. So what happens is there's a little component called a cam. They still call it a cam, but it's a gear. So you can see that there's a gear here. If we flip it over, hopefully we can see it properly. There's a post that comes off of it, and there's two egg-shaped lobes that as this rotates, the lobes come into contact with the tappets that are connected to the push rods. And that is located in this gear right here. Okay, so this gear is still attached. This is just for an example. And as these rotate, they're offset to each other. So they turn and they lift and drop at different intervals. That in turn pushes on the rods on the inside of the combustion chamber here. We're going to pop this off. And the rods come up through and they push on your rockers. So the rockers, this one only has one that we've got on here, move up and down like a rocker arm onto springs that resist that, which are attached to valves. Our valves are in here, our intake and our exhaust valves. And these are what open and close in timing to allow for air fuel through your system, your combustion cycle, and then your exhaust cycle. And they have to come close, open, close at specific intervals. And these rods do that. So they push up and down, and that's what creates a push rod engine. So you can see that if you do get out of timing, something skips, a gear skips, or you put too much stress on the shafting, you may drop out of timing and you may bend your rods because things aren't opening the way they should be. That is the one downfall between the two. More moving parts, more things to go wrong. They're standard in the industry, don't get me wrong. This is the staple of small engines. It's just they're inherent to things that can go wrong with more moving parts. This is much more efficient when it comes to cam-driven engines. These models are also horizontal shaft products. So I'm just going to spin one around here just quickly. So if we were to spin all these around, the first thing you're going to see is the shaft coming out. This is our output shaft. So this shaft is horizontal in relation to the engine. These have to be kept in this orientation. You don't want to take this engine and try to mount it vertically. We have other models for that application. Those are vertical engines. So anything that you're attaching this to, you always want to try to keep this engine in this orientation. Even if it's something that needs to swing, like a post hole auger, maybe it's a standalone engine that's running maybe a hydraulic power pack. Well, as that auger goes down, quite a few of them have a carousel that actually swings. So as you change the pitch of that engine, it stays level, almost like on a gyro. So you want to make sure that these stay in this position. If you start tilting them or mounting them in a different orientation, you will have problems instantly. The oil needs to be in the oil crankcase. We don't want the oil coming up towards the pistons because that will cause hydrolocking. You'll damage your piston. You may even blow the head right off the engine. We've seen engines come back like that. So the oil needs to be down in your crankcase down here and at a certain level. And we'll get into those levels later on. So keep that in mind if you are designing and you're looking at any of these engines. How is that going to be orientated in whatever it is you're building? Keep it level, shaft coming out. You got lots of options when it comes to what you add to this. So whether you're doing direct drive, whether you're coupling, maybe you're putting belts and pulleys or chains, maybe you're putting a torque converter on. Lots of different ways to transfer the power to whatever it is you're driving. So whether it's the wheels, maybe you want to kind of change the ratio of this to another ratio, then you're going to change it with gears or possibly torque converters or a variety of different ways. So we just want to make sure that you guys are understanding that these need to be in this orientation. You will have issues. Also, when you're trying to figure out, am I building something new? Am I replacing something? The footprint that it sits on, for the most part, they're pretty standard. The footprint has mounting bolts, but is it physically going to fit in whatever it is you've created? Maybe you've built a bulletproof pressure washer cart and you've got handles coming up and you've decided, okay, I've figured out that I need this size engine. And did you think about the clearances? Did you think about the way this was going to mount in that? Those are all considerations you need to take. Now, going back to the shaft design quickly while we've got these apart, you can see here that we have two styles of shaft. This shaft is a tapered shaft. This shaft here is a straight shaft with a keyway. If you are replacing an engine, so let's use an example of a generator. Maybe you bought a generator online or at a garage sale. That generator, the engine's just not working. So you come to Princess Auto and you're looking to replace that generator. Yes, Princess Auto has that engine size. So you buy one and then you pull it out of the box and then you realize, uh-oh, there's a problem. Generators, the alternator on the generator, doesn't typically use a straight shaft engine. It will use a tapered shaft. It's basically a friction fit over the generator or alternator on the generator. So all of a sudden now, your engine isn't the right engine for that. We don't carry that style in a box on the shelf. So that's something you'd have to do some research on. Likewise, if you had a water pump that maybe the engine, like a 3-inch trash pump, and the engine wasn't working too well. That one also has a different style of shaft, which would be a threaded shaft. So it actually has threading where you thread the impeller on. So there's a few different styles of shafting, whether it's horizontal, whether it's vertical. You just got to make sure that when you're selecting an engine to replace an engine, you know all of the nuances around what that output looks like, because you may run into the issue if you hadn't taken everything apart. Not everything is equal, even if it is horsepower and same design. So just keep that in mind. The shafts are of varying styles, and a lot of them have threads on the inside of the end of the shaft. Some are metric threads, some are fine thread. If you're not sure, sometimes that information is a little harder to find. The manuals that you can either buy with the products or you can download or open up the PDF manuals on our websites. They will tell you on the front copy on the specs of that what size bolt and thread that is, so that you can find something if you do need to bolt onto the end of the shaft. Well, that's it for Tech Tips with Mike T. We'll see you next time.